Ladies and gentlemen, welcome back. We're back here at KubeCon North America 24. We're in the beautiful Salt Lake City, Utah. I am drinking something called a dirty soda. I don't know what this is, but that's what the locals like. I am joined by Peter from Ampere Computing. Peter, welcome.
Thanks for having me. Appreciate it.
How's KubeCon so far for you?
Oh, man. Well, you know what? I've had a lot of fun this morning working with your team on setting up some demos, and it's really pretty cool to see all the activity around the booths, around the kit that they have running, using the latest, latest releases from the Harvester and all that stuff.
So not to interrupt you, but for our SUSE virtualization booth, we have a big Ampere box over there. Is that correct?
Yes, we have a bunch of them.
I always saw that one big one.
So I can give you the lowdown of what the
what do we got going on
brought
over there.
So in the my buddy Alejandro, who's presenting all the demos, he's got a HP RL300,
okay,
which is the first offering from HP that includes an Ampere processor in it. It's also the first enterprise server that you can buy from HP out of the box with open source firmware. He also has a new System 76 platform that has inside of it an ASRock rack motherboard with an Ampere, I believe it's an Ampere Ultra processor in it. So you're talking 128 cores. That platform itself was basically specifically built for automotive autonomous development. So like those platforms.
Wait. You did a System 76 with an Ampere chip in it? Is that what that's
It's brand new. Just got released this week, I believe.
Oh my God.
Yeah,
okay.
it's a beauty. It's come with GPUs.
And for those who don't know, Ampere, these are ARM-based chips.
Correct. So ARM64 runs, all the latest, greatest Linux distributions, basically. It's, as typical Ampere platform, we bring the cores, right? So it's an Ultra family, so that means you could have an 80 core or 128 core. I'm not sure if that one specifically, some of the units, they throttle the clock frequency, so that way they can be passively cooled. So, and I know with this one of the things that Alejandro and I were laughing about was that when we turned it on, we couldn't hear it. So we had to go and feel the fans to make sure that, is this thing booting?
Is this on? Does this work?
So it's pretty, that part's pretty crazy, and getting used to, I guess, having systems in this day and age that don't require active cooling and fans, it's crazy.
Different.
Yeah.
So it's out there. It's running our Harvester or SUSE virtualization just fine. We're demoing on it.
He actually installed it in under 14 minutes on the System 76.
All right, I'm not gonna lie. My NUCs at home can't install Harvester that fast. It's usually about 30, 31, 32 minutes. It's at least a half an hour. I just go eat lunch, come back. I'm like, it's still not done. All right, we'll be back.
Yeah, no, I gotta say, that's one of the things. We've had one of our guys in-house using the Harvester stack for a couple weeks now, and he came back. He's like, yeah, this thing's no joke. Yeah. It's in terms of ease of use, virtualization, having the containerization there as well. It's a great platform.
So we're at KubeCon. We announced SUSE AI, and I'm not going to say it can or cannot run on an Ampere machine because I don't know, so I don't want to speak. So don't hold me to it. But what do you guys have? We announced AI. What does Ampere have this year? Anything to talk about?
Oh, absolutely. We've been focused on AI for specifically inference for about 3 years now.
Okay.
We have a software-based accelerator that we offer, as well as some tuned libraries. So PyTorch, I don't quite know all of them off the top of my head, but essentially you can take that, utilize it to help accelerate your inferencing. One of the other things is, typically when people use a GPU, for instance, it's only about 60% efficient, right? So yeah, it'll run and be performant, but that's a $40,000 part in some cases, right? So when you think about it from that perspective, if I'm only using that $40,000 part at 60%, I'm not getting my money out of it, right?
Yeah.
So one of the things that Ampere specializes in is the accelerating of inference, and we look at it as, if you can deliver this almost, not necessarily identical performance, but close enough. And when you look at the cost of operating that, in some cases, if it's a GPU, you're talking at 18% the cost, right?
Wow.
So and I just found out recently if you were to have a bare metal system packed with GPUs, you're talking about $25,000 a day if you're using it out of the cloud, right? So from that perspective, anything you can do to, reduce that spend, right, while still delivering and operating the same application is huge. And from an inferencing perspective, let's be real. Once all the training's done, we're all just going to be running inference. So being able to do that on only CPUs, and especially when the current industry, if you went to OCP anytime in the last 2 years, all the discussion around AI, of course, naturally leans to liquid cooling, right? Because the amount of heat being generated by these things, when those parts, that GPU uses about 2,500 watts of electricity, right? You're typically in the models that have existed previous, not AI models, but the deployment models, right? They would put 2 Intel Xeons in front of those GPUs. So you're talking adding 1,000 watts of electricity in front of potentially 8 times 2,500 watts, because if you're in the big chassis, it's a scale up in a single node, right? So you pack the node with GPUs and then interconnect the GPUs, but you have to clear 3 rows of racks to pull the power back in, right? To power that, to create enough airflow to actually cool it based on the heat, if you're gonna air cool. And I'm from New England, where we have a lot of data centers in the Metro Boston area that are never gonna go away. A lot of the telecommunication industries, these are buildings, little brick nondescript buildings that now need to add exponentially more compute in them to help meet the demands of all this, data that's flowing, the streaming services, all that stuff. So when you look at it, something has to change. Liquid cooling isn't going to be for everybody because the barrier to entry is extremely high. Also, in today's day and age, where we talk about things like PFAS chemicals and plastics and all that stuff, the liquid that they actually use to cool, I believe, best case scenario has like 18 PFAS, worst case scenario is 200. So Ampere is trying to make a very conscious effort, right, to allow you to continue to do, to move forward in AI, to do it, but do it in a model that allows you to retain your data center,
it's just better for the environment.
Absolutely.
It's just better for, you can just sell me on this. It's just better for the environment. That should be the only reason right there.
Yeah, but it's not. The reality of it is, that's one piece. Everybody uses, we will consume as much electricity as possible, right? So being efficient is a way better use of that electricity, and that's how Ampere looks at it. It's efficiency.
So if anyone wants to find out more about what you guys are doing over there at Ampere, where can they go?
Come check out amperecomputing.com. Check out our solutions portal on our website. You can also check out developers.ampere.com. Come join our community. We'd love to have people who are interested in coming to find out use cases or share their experience, or just come ask questions.
Awesome. Well, Peter, thank you very much, and we'll see the rest of you guys in the community.
Thank you very much for having me.